The computer is reporting a previous voltage failure warning. Windows XP still boots, and that's good. Let's look inside the computer and try to identify the problem. This is a Dell Precision 450 workstation circa 2003 through 2005. It features sockets for two Intel Xeon Prestonia CPUs. Did you notice the tops of the VRM capacitors? The electrolyte is leaking out. The electrolyte boiled inside the capacitors and vented out the tops. The electrolyte leakage is a good indicator that the VRM capacitance has significantly dropped and ESR has dramatically increased. ITSD Data Recovery presents tips for soldering to large printed circuit boards. There are a total of 21 VRM capacitors, Nichicon 2200 microfarad 6.3 volt rated electrolytic capacitors. Let's remove this bank of two capacitors first. Even though these capacitors did not leak, their tops have bulged, which indicates they should be replaced. Next, let's inspect both the original and the replacement capacitors close-up. The factory-installed original capacitors are rated for 6.3 volts and are 10 millimeters in diameter and 20 millimeters tall. The replacement capacitors purchased are Panasonic, 10 volt rated, and are 10 millimeters in diameter and 25 millimeters tall, which is 5 millimeters taller than the originals. A higher voltage rating will increase the capacitor's lifespan and allow them to tolerate higher voltage transients. Taller capacitors have the advantage of being lower in ESR, can withstand higher ripple currents, and dissipate heat better than shorter capacitors. Almost all of the original VRM capacitors have either leaked from or bulged at their tops. Notice how the original capacitors wobble when placed upside down, but the new capacitors lay perfectly flat and still. Remember when buying replacement parts to buy in bulk to obtain the lowest price per part. Let's get to work replacing these two capacitors. First, let's find the capacitor's solder joints located on the underside of the circuit board. Here they are. Next, let's turn on the fume extractor and add some flux to the solder joints. Now let's add some low melt solder to the joints. While I prefer tin bismuth solder, regular tin lead solder will also work. Lastly, heat each solder joint to liquefy the solder while gently rocking the capacitor back and forth from the other side of the circuit board. One capacitor removed, one to go. Let's repeat the same procedure with the second capacitor. Once both original capacitors have been removed, the next step is to remove the excess solder from the holes so the replacement parts can be soldered to the circuit board. I prefer to use solder wick. I also set my soldering iron to at least 400 degrees Celsius. If a hole cannot be cleared of solder, add more flux and low melt solder to the hole and try again. The newly added low melt solder is easier to remove than the original solder. When all of the through holes have been cleared of solder, clean the circuit board using isopropyl alcohol and cotton swabs. Here are 5 tips for soldering to large printed circuit boards. Tip 1. Use standoff screws. They enable one to flip large circuit boards over and back again with ease without needing any additional stand, vise, or holder. The best locations to install standoff screws are in existing screw holes. Notice how easy it is to flip, move, reposition, and align the circuit board. Using a stand, holder, or vise would take much more time and would be more difficult to use. Tip 2. Use a chisel-shaped soldering iron tip. Chisels have a large thermal mass and can both store and transfer heat well. Tip 3. Use low melt solder to remove parts as it stays molten longer. Chisel tips are great for soldering through whole components and for removing solder with solder wick. Remember to use high heat when removing parts to help keep the solder molten for as long as possible. I recommend using at least 400 degrees Celsius. Tip 4. Use no clean flux to aid with solder flow, protect the circuit board, and prevent the formation of oxidation. Tip 5. When using solder wick, pre-cut the wick into small pieces and remember to only dab the board as brushing may cause damage. Here's the circuit board with all VRM capacitors removed. New CPU 0 capacitors installed. New CPU 1 capacitors. And new main VRM capacitors.